Hello, my name is Brian Berger. I'm the editor of Space News, and it's my pleasure to welcome you to today's fourth and final webinar of the Space News at SmallSat webinar series. Before we get started with today's panel discussion on building small satellites for big missions, I want to share a few housekeeping notes and also put in a quick plug for some of the great work the Space News team has been doing this week. First, with the housekeeping notes, we will be getting to some of your questions for our panelists today. In order to submit your questions, I ask that you please use the Q&A function at the bottom of your screen. There's both a Q&A function and a chat function. The Q&A function is what we prefer you use for submitting your questions. Those questions are primarily only being read by the Space News team, so you can you don't need to put any sort of introductory remarks in there or greetings to our various panelists. Just be succinct with your question. That helps us filter through them so that we can ask them of our panelists. Beyond that, I want to remind everybody that they still have a chance to download the latest issue of Space News magazine. The August 3rd issue was written with SmallSat in mind. There's some great stories in here. That's available both on the SmallSat webpage and also on the homepage of Space News. So this issue is free this month. Please download the PDF. I don't think you'll regret it. I think that's about all I have to say. You know, I can't believe that we're coming to an end of another SmallSat. This time without having to drive back down to Salt Lake to catch our flights home. Nobody has to pack up any exhibit booths. Find room in their suitcases for all the swag they've picked up along the way. Any swag that's been offered this week has been done largely via Twitter, and I think it's going to be delivered conveniently to your home if you were lucky enough to win any of the giveaways. You know, hopefully we'll all be together next year in person. Online conferences, you know, they're still valuable, but there's just really no substitute for the serendipity that goes along with actually being in person. But we're doing what we can under the circumstances. And as part of that, we're trying to provide as much interactivity as we can. And we should just get into it. Right now, I want to introduce the moderators for today's panel. We have Caleb Henry of Space News, covers telecom for us. And we have Debra Werner, who covers a lot of startup activity out in San Francisco for us. Covers it around the world, obviously, but that's where she's based. So it's my pleasure to hand it over to Caleb to tell you a little bit more about today's panel discussion. Caleb?
All right, thanks, Brian. Yeah, I'm really looking forward to today's discussion. We've got 6 great manufacturers of small sats, each with their own unique businesses and perspectives. We're going to be talking about the things that are driving their business, some of the trends in technology that they're seeing, and also how they're seeing small sats adopted for commercial, government, academic, various applications. So I'm actually going to hand it over now to Debra, who's going to quickly introduce our panelists, and then we'll jump right into the discussion.
Good morning. I'm delighted, or for our audience, good evening or good afternoon or wherever you are. I'm delighted to introduce Craig Clark, founder of AAC Clyde, Marco Villa, CEO of Tyvak International, Tim Lynch, Director of Multi-Domain Architecture Group for L3 Harris, Brian Ryder, LeoStella, Chief Technology Officer, and Chester Gillmore, Vice President for the Spacecraft Division, Spacecraft Development and Manufacturing at Planet. So welcome, everyone. And Brent, I thought we would start with you. NanoAvionics has announced a lot of contracts lately, and I wanted to ask you what you think is behind that and how important price is in this equation.
Price is almost always important in the equation, but it's never usually the only thing. Where it always usually comes down to price, but people usually, primes usually have to vet to see if someone's credible, if they can meet the technical hurdles and can meet deliveries and other things. And then it usually comes down to pricing in my experience. So there's a lot of hurdles to go through. So it's never just price, but it usually comes down to that in the end for selection, in my opinion. And Our growth definitely has been in expanding our share of the existing market base for NanoAvionics based on our entry points in low cost points and credibility in the markets and our experience on orbit. And then we plan on growing more as we have done per the recent announcement with the growing of the market.
Craig, you spoke at a conference last year about price and the cost of CubeSats. Did you have any thoughts on this topic?
Yes, I do. From obviously, CubeSats are something that we are been involved in for a long time. There is the number of CubeSats being produced is certainly going up, but I don't think that we're at a point yet where we can see the volume driving the price down. It will happen. With mass production, you know, there becomes an opportunity to really reduce the costs and therefore reduce the price to customers. But we're certainly not at that point. And I guess what worries me about our market is that you can have new entrants to the market trying to gain market share by aggressive pricing, which basically devalues what it is that we do. Building satellites is very difficult. Building satellites that work and do the job well is a difficult process. There's a lot of design or test, manufacture, product assurance. You know, unless you're building tens, if not hundreds of spacecraft, it's difficult to then automate that fully to the point you can really drive the cost down. So, I mean, we don't compete on price. We compete on the fact that we've been doing this for a long time. We've got lots of spacecraft in orbit, and our customers are sophisticated customers that value that. So we're going to continue to do that, but our price will ultimately come down as we make more and more spacecraft, and we are planning that, and it's in our development strategy. But it does concern me about new entrants driving prices to below what they should be.
Did anybody else want to comment on that?
Well, I tend to share, here is Mark, I tend to share what Craig said. It's, I think I share with him, we've been around a little bit. We have seen some new entries coming in and trying to, you know, rightly so, gain some market share. And you do that in different ways. There is nothing, either by a complete revolution in technology or some great offering that it really is a meaningful step function, or you do it by altering a little bit the status quo, and kudos to that. But the long game and the long term is the one that is important. And again, technology is going to keep on progress. Prices are going to keep on coming down because of that. But the cost of quality assurance and mission assurance is the one that sooner or later people have to deal with. And the only way to retire that is then to have increased numbers in production. And that is something that every company eventually goes through that and is going to have to tackle.
Are we getting to the point where we're increasing production numbers? Are you getting larger orders now?
If the question is to me right now, absolutely. It's every single industry and every single customer drives in the same methodology, with some exceptions here and there. But everybody wants to test the water, both in terms of partnership, in terms of technology, very often in terms of is this the right idea? I see everybody doing it. Am I missing something here? So they want to test their business plan. They want to test their customers and see how they're going to react to shifting from a traditional approach to a small satellite or nano-satellite approach. And that is always in the low numbers, right? From the 1 to the 3, the 1 to the 5. And the second phase is, okay, I understand that it's valuable. We have mission success. Let's give it a shot to now grow the market share in the downstream and see how many satellites we really need, or what infrastructure we really need to then expand and execute. And then the third phase is, okay, now we have proven it, now it's time to do it. And so there is the big order. We have customers personally in all three of these different phases, and you have to keep on having them on all three phases because you never know what's going to happen. So we certainly are seeing a huge increase into production of the same spacecraft, which is different than overall production across the company. And some new entries that are adopting. The important thing that we're seeing is the time between the first phase to the third one is shortening tremendously. And that tends to leveraging on each other production capability and piggybacking on the satellites where we have.
What did you mean about the shortening time between the orders, between them ordering the first?
Yeah, it used to be, so somebody finds a little bit of money from friends and family, enough just to build one satellite or two because they have a good idea. And then after that satellite launch, and there is some success, they go out and raise some funding, the Series A, and to build 3 or 4 or all the way to 10 or whatever is the right number. And after that is successful, they go out and do another raise to raise enough to build more. The more we dilute that through the development process and the launching process and the operational process and the financial raise process, that cycle we have seen on our early customer can take 5 years, 6 years by the time that all the things comes into play. That's why there has been the slow burning, and now we're seeing some results out of those early investments. And very often we had to invest in our customers to make that happen. Now that time shortens because, well, we got much better in delivering much faster, and they have understood by the business plans of other people that they can take the risk, and so all of that compounds into a shorter time from beginning to the end.
That's interesting. Tim, I wanted to ask you about how the government market is shaping up.
It's shaping up quite nicely. The interesting thing about the government, it's a large marketplace with a lot of missions, and the mission spaces are very diverse. You have RF, you have EO, and of course, there's always a threat. So they're always looking at how do you solve the problem against that threat in the most economic way. And most of the time, it's some type of responsive space application. It could be a small sat, a medium sat, a large sat. What we found is there's an optimization function. It may not be solved completely by the small sat, the small form factor, but it could be piece of the equation. So what we're doing is a lot of optimization functions for mediums, smalls, larges working together in concert and utilizing multi-domain effects to solve the warfighter's hardest problems. And kind of commenting on Marco's statement about trying to build multiple satellites in these droves. What we're trying to do as a prime integrator is making sure we're common platforms. So we may have an Air Force customer, we may have a Navy customer, an Army customer, but we're utilizing a lot of the same framework and architecture so that we can get economy of scale of the manufacturing processes. And that's how we do it as a prime integrator, trying not to make every single one of these satellites a unicorn.
All right, Caleb, you wanted to jump in.
Yeah, so I wanted to ask some of the panelists about CubeSat or SmallSat reliability. My colleague Jeff Faust recently wrote an article about a study that showed CubeSats and SmallSats are becoming more and more reliable. They're not failing as frequently early on in their mission. A lot of that report was actually influenced by Planet because so many of the satellites were from Planet. So Chester, it'd be great to hear from you as to what Planet has been doing to improve the quality of the Dove spacecraft.
Thanks, Caleb. I think Planet's very fortunate in the fact that we're actually not selling satellites. So essentially what we're trying to do is index change on the Earth the way Google indexed the internet. And we provide a platform and data delivery to solve our customers' problems and challenges. And so because of that, there's a lot of internal risk that we can take in terms of how we progressively build and test. But also because of the need for the data that our platform has, we've been able to build at an incredible rate. So what that's allowed us to do is essentially, I think last year we launched 4 times. We've launched over 30 times in the history of the company. So we're essentially always building and launching something. So what we do is we have a multi-prong approach to quality assurance into how we do qualification and test of new hardware. One is obviously a classic ground test campaign where we do all the ground testing, but then we ship a satellite to orbit, and then we also gain heritage. And sometimes we'll do that before we complete reliability testing on or lifetime testing on certain subsystems. So we're basically able to impedance match what we're seeing on the ground with what we're seeing on orbit to constantly be updating our models and to be getting them better better and better at how we do ground test and reliability. And the other thing is, because we are building a constellation, not single spacecraft, we think about reliability in terms of the constellation and providing, continuous data to our platform and our analytics team. So we're able to take some risks in terms of, looking at subsystems in terms of criticality. Obviously, the cameras have to work, the radios have to work. But let's say we have early degradation of a power system of a newer generation satellite. It's not catastrophic for us because we can toggle the duty cycle of that particular satellite. And the main KPIs that we track are uptime of the constellation. So I think that we're very fortunate in terms of our approach to reliability, because we actually have very, very good data and statistics from on-orbit heritage spacecraft. And we also have had, in the 8 years since we've been, building and launching satellites, we also have extensive ground testing and extensive lifetime testing that we're doing on subsystems that we developed internally. And it's really interesting to see the correlation between the ground testing we do and then the heritage that we get. And oftentimes we'll look at the test campaign, we're like, well, okay, that test was mostly good, but not quite good, because it's failing on the ground, but it's working in orbit. So either we were too aggressive with how we were stressing on the ground, or vice versa, where you see something that looked great on the ground, but you had some critical escape because some condition of the environment we weren't able to properly model.
Okay. Brian, I'm curious from LeoStella's perspective. So you have Thales Alenia Space as one of your investors, co-founders. They're used to building spacecraft that are in orbit for 15 or more years. Yep. You're focused on small sats, and you also have spaceflight as your partner. But how do you balance all of these influences that come in for manufacturing satellites at LeoStella?
Well, Caleb, thanks for the question. I think that's a really interesting dichotomy, actually, between very highly reliable, long lifetime, mostly geosynchronous technologies versus lower cost kind of demonstration missions with really tight cost constraints and also very rapid schedules. What we find is really a unique balance, which is the most of our customers, the commercial constellation owner operators, they don't just need the lowest cost satellite and the highest risk satellite. What they really need is what I call a commercially operational satellite. They need to be able to rely on that satellite to work. They need to be able to get the efficiency and the availability out of it. It's baked into their business models. If they don't get that, then it's really just a loss of value from an operations perspective and from an infrastructure perspective. So what I think, something that we try to do with our shareholders, Thales Alenia Space, and also Black Sky, is we try to find the way to blend those two things together to make sure that we have the right amount of mission assurance built in to provide that operational confidence and get a lot of that heritage from the more robust systems and the very detailed systems engineering approaches that Thales Alenia Space has developed, as well as mixing it into a commercial model and understanding how that interacts with a real commercial business plan through our experience working with Black Sky. So those are two very different things that really allow us to try to navigate the middle of that trade space.
And how important, going back to the subject of price, when it comes to satellites that LeoStella builds, do you see yourself competing aggressively on that, or is it quality or other aspects that you would see as LeoStella's strong suit?
Yeah, well, cost always matters, right? Everybody's got to pay the price tag, and everybody cares about what those dollars look like. But I think that what really drives it, what I see really drives it, is, especially in a commercial investment-based business plan, what is the best bang for the buck? A lot of especially the early stage constellations really need to demonstrate to their investors that they will get something valuable and that they'll get to a minimum viable product. And getting to that product often requires a certain size constellation, so that absolutely puts cost pressure onto the production and the space infrastructure. But it's also equally important, the performance and the on-orbit operational value. Really, how many dollars can they squeeze out of that infrastructure? How many pitches can they take? How many communication channels can they keep open? That value proposition is a really interesting point. So what we try to do is we try to work with our customers to the extent that we can be supportive of that, to understand really the trade space from a business plan perspective, because it's really the business plan that drives it. It's not simply the cost of a satellite. That's one part of it, but that's not the whole equation.
Tim, I'm curious if you have the same thought or different. Like L3Harris, your customer is mainly the government. What do they come to you wanting most? Is this price, reliability? How do you convince the government that CubeSats, which I guess until recently were pretty failure prone, are now something that can do serious government missions?
Yeah, that's a great question. First, we don't really say CubeSats in our marketplace. You know, we look at it from the mission perspective. Chester was really discussing his business models, delivering product and services. Ours is similar, but to the government. So when we talk about problem sets or, you know, warfighters gaps, we talk about how we're going to solve them. And we show them utility of a responsive space approach, and that may include a small sat. But we typically don't say CubeSats. I mean, CubeSats have a certain connotation about them. They're super small. They're cube the size of Rubik's Cube, right? 1U, 14 kilograms. Most of the satellites we build are about 100 to 125 kilograms. That's really where we find the sweet spot to be able to host a sensor or a mission processing environment that has enough utility for the government to make decisions. And that's what it's about. It's about making decisions. So we look at it that way as opposed to CubeSat, SmallSat. We're trying to solve a problem. When we have high officials and government officials in our plant, we don't come in there and say, hey, look at our CubeSat. You know, we show them products and services and data that we can provide them so they can make actionable intelligence, decisions. So that's the approach we take. And to be honest with you, I really don't care what size the satellite is. You know, I'm trying to get a certain amount of utility, a certain amount of uptime, orbital duty cycle, orbital average power, agility, all play into this equation when we look at the satellite. First, also, we keep talking about the satellite, the bus, the actual satellite. I mean, there's a mission, there's a payload, and there's a cost of that too that's rolled into it. And that payload cost is part of the system cost. Additionally, when you cut corners on mission assurance on a satellite, you're just pushing the problem to the ground or developing another software package or a recovery package to get that satellite back online. So you're really just moving cost around. You're really not eliminating it because you're going to have a certain amount of, operational needs from the ground to keep your constellation in an operational mode to provide those goods and services or that uptime you promised your customer. So that's just one note from the earlier conversation about mission assurance. It's system product mission assurance. It's not just a satellite mission assurance.
Is it okay if I jump in here now? So Brent, you've been moving aggressively to expand in the US market. What are your plans there?
So we're set up here in Illinois, Southern Illinois, in the St. Louis area, right across the river from St. Louis. And what's unique is it's the only satellite manufacturer in Illinois and the Midwest. And we've got so many great universities with CubeSat programs now. It's fantastic and good talent to pull from. So we've got a lower cost base here in the Midwest compared to the coasts, and able to get and retain people in a better way. So we've got a full integration facility here. Our parent organization, AST in Science, has a really big facility. If everyone remembers XCore, they bought that facility in Midland, Texas. We've got that to outfit for any large quantity orders as needed. So that's our expansion plan. Plus, we'll probably outgrow this facility here in Illinois and grow to another building here fairly quickly. We're expanding, like we said before, because we're not only have a good price points, but we're able to be responsive. Customers get that's number one feedback, and being able to pick up customers from some of our competitors in that area. And we expect with that growth and the growth of the economy, the market, it'll keep going. I don't think we're going to get any of the giant constellation systems. Planet Inspire examples of, they'll bring that in-house. OneWeb, they'll be building internal for the really big constellations, but for all the ones in the sub hundreds and stuff, or down to the 20s, or everyone always starts with a few. That's what we target, and then we grow from there. Plus, there's some constellations that we're looking at growing organically with our expertise that we've developed through the years. So we might potentially be a data supplier in the near future as well.
Craig, you merged with AAC Clyde. It's been a couple of years now. How has that changed your business?
Yeah, it's been really interesting because before we were a private company and now we're listed on the NASDAQ in Sweden, which means we've got much easier access to capital to grow, which is what we're doing at the moment. So we've raised some money over the last year or so. We also have recently been awarded a grant from Scottish Enterprise, I think about $3 million or so. And that's really focused on developing our platform technologies and taking them to the next stage. So we currently have our Epic platforms, which are CubeSats, and I don't mind calling them CubeSats because CubeSats have been really good for AAC Clyde Space over the years. And I think it's a really great platform from a standardization point of view. And the grant that we have is all about productizing our satellites further to make them much easier to build, much easier to test, with a view to doing the tens and hundreds as the market continues to grow. We see that as really where we need to take our business. It will make it much easier for us to quickly turn around lots of spacecraft. And I think that the type of customer that we're working with these days, with like Eutelsat and Orbcomm, we want to develop those relationships. Really, I think that's one of the most important things for us, so that we can meet their future constellation needs. So a lot of our new developments are focused around that type of customer and securing that future work. But things are good.
We had a question from the audience about the next technological leap in CubeSats and small satellites. Do you have any thoughts on that?
Yeah, well, the pace. So whenever anyone asks me about CubeSats and they say, well, why don't you go bigger? Because a lot of people do. Well, I always say, well, if you look at the advances that have been made in CubeSats in the last 10 years, the applications that we're serving now with a 3U CubeSat is far beyond what anyone would have expected even 5 years ago. Data rates are like through the roof. They look at the imaging systems that Planet are now using on their CubeSats. I mean, there's so many different areas where we're expanding the utility value. So that's going to continue to increase. I think the key things for us, the most important technology advances are going to be in thermal management. Where we need to dissipate hundreds of watts on a very small satellite. It's really difficult to manage that. Pointing is also going to be difficult. For example, star trackers with a baffle on a star tracker is bigger than a CubeSat. So how do you deal with that on a CubeSat to get pointing to the level you want it to be? So we need different types of sensors. We need better algorithms. So there's a lot of activity going to be going into that. Then of course, there's generally just power generation and power storage. I've never been a big fan of articulated panels because it's one of the things that fail most on satellites, and especially I think on very small satellites. But I do think that maybe I'll need to change my opinion on that, and we might need to start thinking about articulated panels in future, because power is also a main driver. I think that was said in one of the other panels earlier in the week as well. I think that's my take on it.
So Tim, I see you nodding your head about the thermal management question.
Yeah, so these technologies, I mean, they're obtainable. You got NanoAvionics, of course, and we build electronics packaging in very small volumes, and getting the heat out is tough. And thermal management is a big deal, especially when you talk about high power PAs. If you want to do a modem, to do high rate downlink, I mean, that heat has to go somewhere. So thermal management is very important.
Okay. Caleb, did you want to jump in?
Well, I was going to say, I think Brian looked like he was also agreeing there. I was curious if he had thoughts along the same lines of what technologies are evolving or need to evolve for small sats.
Technology, that's really the fun part of this whole industry, isn't it? I completely agree with Craig and Tim on, as we continue to deploy more capabilities, whether it's a CubeSat format, a microsat format, or what it is, we're going to continue to add more, especially processing power to it. So dealing with the thermal management and dealing with the computational power that we put on the platforms is critical. I think that also kind of taking a step back and looking at the architecture, having platforms that we build in a very high degree of scalability, I think is absolutely critical. One of the trends that we see is the need for constellations to be able to quickly evolve and quickly insert new technology. And having that scalability and the flexibility in the satellites and the payloads, I think is critical. Then also things like adding a very high degree of security, whether it's blockchain or other approaches, I think is also going to be critical, not just from an operations, but also data and a data management and data security system. Autonomous operations, obviously really important. DARPA is doing a lot of great work with their partners there. And then also I think the other piece is really about the responsiveness of the constellation. So having constellations that are connected and that are connected with decision makers to allow real-time decisions, to really take the latency out of the operation cycle, and also have some sphere in some applications where constellations can be aware of each other and what they're doing and be able to act as a coordinated capability, not just a series of many different capabilities or independent capabilities. So those are the trends that I'm looking forward to.
Yeah, I'd like to add something to that. At Harris, we're known, or L3 Harris, we're known for high compaction ratio antennas, deployables. We have a family of reflector systems called a high compaction ratio antenna. And when it comes to small sats, they're small on the ground, when they're stowed up, and when they get out to space, they deploy, and they're very large. We do have a system right now in orbit, has a 20 square meter aperture that comes out the size of a Keurig when it's stowed. So you're talking about a 5-meter diameter reflector that comes out of the size of a satellite that's a suitcase, where the bay that contains it is the size of a coffee maker. So you can do big missions with small satellites, but it's all about packaging, thermal management, and reprogrammability is huge. You hit that topic. That's a great topic. It's a software-defined radio. I like to call it the angry iPhone model, where you basically can upload applications and you can change the characteristics of the DNA of your satellite on orbit. Very important part of being agile in our mission space.
Yeah, I think that the smartphone in space is the origin story for Planet over here, if memory serves me right. Chester, do you still see that as a driving factor? I'm trying to recall some of the stats for your satellites. I think that a single Dove can store, is it like a terabyte or 2 terabytes of imaging data?
Great. Yeah, it's interesting, the conversations about technology, because what we're trying to do at a very rapid pace is figure out, satellites should be as small as they need to be, but no smaller. And they should be as cheap as they need to be, but no cheaper, right? So we're really looking for optimal value. And the main problem that we've tried to solve for is you have the BOM cost on an iPhone, which is essentially a satellite, is very, very, very low, right? If they, I don't know exactly what it is, but I'm sure we could all guess, but it's in the several of hundreds of dollars, right? The BOM cost, if probably actually less than that for an iPhone or a laptop. And that is a satellite, but we can't build satellites with BOM costs of hundreds of dollars, because the things need to work when they go up into space. So what we've been working at very aggressively, and what we've tried to do over the years, is build a systematic way that we can bring flight heritage to COTS componentry, and to figure out where can we take advantage of Moore's law in terms of electronics, and where can we take advantage of economies of scale that the space industry doesn't benefit from. And it's not a slam dunk, and it's very challenging to do, because the environment of space is very different than the engineering challenges of space are very different than the engineering challenges of a consumer electronic device. So the goal is to continually to launch better and better capabilities and hardware. And because we are delivering, data sets to our customer, we want to provide more and more value because our customers don't buy the satellites, they buy the data. So we want to make sure that they continue to get better and better data. And part of that is how do we make the satellites more efficient from a build and a cost standpoint so that we can make them more capable from a data delivery standpoint. And so like for instance, consumer grade SSDs, some of them hold up very, very well to radiation. Some of them don't. And so having a ground campaign correlated with statistical data from orbit is so important to do at a very, very aggressive rate, because the last thing that you want to do is deploy a fleet of satellites with, with a bunch of COTS that then don't work. So, it's been very interesting and it's a very fun challenge to work on, thinking about, especially a Planet, because we have so much access to launch. It really is a very, very fun challenge for the engineers as we sort of develop this technology, heritage and maturity platform. And really that's, what we're trying to do is figure out how we can get the latest gains that, that companies who are investing billions on the ground into spacecraft in a reliable way that works.
I want to switch to an audience question we got about small sats in GEO. Want to see, the question is, what potential do you see for small sats in GEO orbit? And is this a priority for your company? I think, Marco, you'd probably be best to start on that since you are building a small sat for GEO with GapSat, I believe it is. Can you sort of talk about the business opportunity you see there?
Sure, and we have multiple now that we're building. I'm going to tie this answer to the one before, if you allow me to just do that jump, because we talked about, and we're transitioning away where we talk about pricing, we talk about number of manufacturing, we talk about reliability and technology. They're not children of different parents. They're all coming together all the time, endlessly, into an iterative process. I mean, in our company, we realized that very early on. And it was one of the initial take that we have done, and that's why we brought and we invested a pretty good amount of money in processes and products to do everything in-house. Some of our initial satellites of 6 years ago are still flying, still operational, but we kept on learning over that. And now the third generation, which properly called Mark II, we have modularity. And the reason why I'm bringing the modularity aspect, and we do everything in-house, from star trackers to flight computers to everything else, is because that's the only way to accrue that heritage to actually bring the reliability and the flexibility and the scalability that is needed to then tackle problems like, that's great that you can fly in LEO, that's great that we have been doing it for a while, but what about where else can we operationally serve the needs of the customer? GEO is one of them. So we've been starting the program to fly in GEO, or let's say in non-LEO orbit years ago. At the end of the second generation of avionics that we were flying, we were testing some of the components and some of the processes and some of the software that actually would be needed to then fly in GEO. It's expanding a lot, that demand. It's expanding right now all over the place. There are needs in the very small, let me call it very small tactical satellites that leverage on some of the skills that we mastered in 2016, 2017 by formation flying and proximity operations in LEO. There are needs that are in the 400 kilogram satellites in the small telecom and a lot of other things in between. The only reason why we can tackle it is because we started invested a year ago, and because we have this flexibility in building satellites from the small to the big, using the same pieces. They're exactly the same modules. And so that's why we're doing it. And it's manifesting itself also on very recent 4 or 5 different wins across the world for interplanetary missions itself. Somebody earlier on was saying data anchor from flight to data anchor on the ground, and a very systematic campaign to mitigate risks. And those risks change depending on the orbit you're in and depending on the mission you're in. Being able to always tie that together and to have the software done in-house that allows you both ground and flight to support all of that, that's why we are very comfortable in transitioning to GEO, and we are doing it for many customers.
About how many small satellites are you building for GEO these days?
It's more than 10.
Is anyone else on the panel building small sats for GEO?
I can say LeoStella is not building small sats for GEO today, but I agree with Marco that I think that there's a really good opportunity there. You know, as a society and an industry, we've all invested a lot into those geosynchronous assets, and if we can connect maybe the next generation of GEO birds to have more interoperability with neighborhood satellites, then we can continue to deploy new capabilities, as I like to think of them, as sidecars or expansion packs to your geosynchronous satellites by flying maybe it's an advanced technology small satellite nearby, so and creating a link there. So I think that there's a longer term opportunity there that I am personally very excited about.
I'll say the issue with planet satellites and GEO is you wouldn't see much.
Greg, did you have something to say there?
Yeah, I mean, one of the reasons that we've seen some opportunities to use small satellites in GEO, and in fact, I worked on a program when I was at Surrey Satellites a few years ago. It's an incredibly different environment to low Earth orbit, radiation environment. I mean, geostationary orbit is like gold dust in terms of getting orbital slots for the
it was awesome, and it got
best regions.
by like 4 other places.
But if you were
NPR story got picked up
if you're
by,
building
like,
a small satellite, you then got to prove that you're not going to drift about, hit other
so
satellites up
60,
there.
so
So I think the costs is, you know, to develop. Sorry, I could hear somebody else talking.
Yes.
The cost to develop a small satellite for geostationary orbit is going to be obviously a lot higher, and I think there's a lot of risk. I would be surprised if in the UK you would actually get a license from the UK Space Agency to launch a small geo satellite that's not gone through significant development and tests to make sure it doesn't cause any problems.
Brent, you had something to say?
Yeah, we currently have a partner. We're going to be working on some geostationary, not geostationary satellites, but small satellites out in the geostationary ring.
Huh. Okay. Hey, Tim, I've got a couple of questions here. One is, these are from the audience. Does Harris have any plans to take its government expertise to the commercial market?
We look at it, I mean, fairly often. It's about the monetization function. If the business model closes, it's all about the business model and how much investment is required by us in order to close the business model. It's like how much inventory. Do you have to build the satellites yourself? Do you have to build the infrastructure yourself, the ground? And how long it takes before you can monetize that. Most of the stuff we do is government-based, so it's got a tactical nature to it, or it's got a government type fidelity type of aviation. And we try to see if the commercial market is interested in that. And typically they are, but it's not nearly as high a fidelity. And so we're trying to figure out how to close that business model most of the time. But yes, we always look at commercial markets.
There's another audience question that I would like to address to you about distributing functions among a cluster of small satellites. Do you see potential there?
Absolutely. You know, trying to make a Swiss Army knife satellite is pretty expensive. If you could fly a cluster of satellites, say one has an RF capability, one has an EO capability, one has an IR capability, and then you can communicate within each other and kind of merge that data or fuse that data and make decisions. That is something that a lot of different organizations are looking at, government and industry. But I'd like to also say that communication is the biggest problems that we're seeing with these small satellites. It's the store and forward nature of them, cross links, getting the data to the user, to the edge, to the sensor, to the shooter, and shooter to the sensor. That's really the biggest thing that we're trying to tackle, is that latency for actionable intelligence. And we have a lot of internal research and development and a lot of partners looking at RF crosslinks, laser crosslinks, and of that nature that can fit in small form factors. Of course, they have to have low swap-C because they have to fit on a small system. Because this isn't revolutionary. Big sats have these capabilities. How do we put them on small sats? So it's really about packaging and thermal management.
Yes. We could obviously have this conversation go on for hours, but I wondered if any of you have other comments that you want to make on this topic before we come up to the end of our time.
I feel like I'll just add one thing to what Tim was saying right now, because this last aspect of the multi-dimension and architecture, I have always seen it and I remember even talking to Greg back in the days. This is not something new. This is the reason why we have been building these building blocks for so many years and getting ready, kind of understanding how interoperability, intercommunication, and having this resiliency in all these different nodes that work together. That's where really we're going to see the exploitation of all of this investment that through the years has been happening. So some areas that have already been adopting it for a while, some areas, especially in the commercial, they're still more on the single one and then eventually grow. But it's an inevitable aspect if you really want to exploit to the maximum extent.
Craig?
Just a final comment from me. I think that we're at it's really exciting time for small satellites, and it's been really good to hear the different panels over the week from the launch companies, and you see all the different launch vehicles that are being developed. We do see there's still investment getting into our sector. For me, I'd like to see more applications come forward faster from government and commercial sectors and use the supply chain. I mean, all of us sitting here are working very hard to make our products as reliable and as cost effective and offer as much value as possible for these new applications that are coming through. And, I believe that the supply chain is ready to start supplying. I totally understand that why Planet and Spire go off and have made their own spacecraft, because the supply chain wasn't ready at that time, but it is ready now. And we are, just champing at the bit to get making hundreds of small satellites for people and get using these new launch vehicles that have been developed. So I think it's exciting times. I'm sure it will happen, but let's go for it.
All right, well, Chester.
Yeah, I was just going to say, I want to echo what Craig said about the exciting times in small satellites. I think what we were trying to do wouldn't have been possible certainly like 15 years ago. And even if I go back 8 years ago, our onboard storage, we had 16 gigs. And now, as you mentioned, we have 2 terabytes. And that's as a result of, industry change and the miniaturization of electronics and components. It breeds its all other challenges, Tim and others mentioned, with thermal management. But the exciting thing is what's been made possible, whereas once, the capability that we can pack per kilogram now is really unprecedented. And what that allows us to do is launch more and more and deliver better and better data products to the customers and to the world, and look at how these applications can actually start to affect and change people's lives as they're looking at, farmers, whether farmers are looking at, at how they're producing food in a safe, securable way, or whether we're looking at like disaster response and mitigation. And I just really think this is made possible because of the coattails of what's happened with technology. And I really can't wait to see what's next and how we can continue to, innovate and continue to try to drive this industry forward in an agile way.
Tim, it looked like you wanted to say something.
Interesting enough, we started with large sats, 10,000 kilogram satellites. We got down to a few kilograms for a satellite, and we've worked on packaging, electronics, thermal management, and we got to this form factor that's extremely agile, and the mission assurance is starting to get very, very, very much improved. What's interesting is we've actually used small sat electronics on large satellites. We went the other way too, because what it's done is it's given us more bang for the buck in a smaller volume. We're able to put more payloads on larger satellites now, because some of the prototyping we did on small satellites, or some of the technology advancements in these small sats, technology mission assurance has got to the point where it's effective and available and can run 5 to 7 years, and we can put it on a large satellite. So we've actually won large satellite programs using small sat electronics. Funny enough, huh?
Yeah, that's very interesting. I think we might as well I think everybody's giving closing comments except Brent and Brian. If you guys had anything you wanted to say, and then we'll wrap it up.
Sure. I think that what I like about this discussion the most is the fact that it's not just a discussion about how do we optimize satellites and constellations, because we can, but really when you look at speed, agility, scalability, and modularity, these have now really become market requirements and business case requirements, not just industry buzzwords. So I think we're really where the rubber meets the road on this. And I think that that's what I find really exciting.
I just appreciate the opportunity to participate on a august panel.
All right. Well, thank you all for joining us. I think this was a great conversation. We're going to have, after this, just a roundtable with the reporters of Space News, and we're going to conclude. I'm going to pass it over to Brian now, but to all our manufacturing participants, thank you so much for your insights, and we really enjoyed the conversation.
Thank you.
Thank you.
Yeah, thanks everybody, and for all of our for everybody watching today, don't log off. We're not quite done yet. We do want to talk a little bit about our key takeaways from this year's SmallSat. We will get you out of here in time so that you can join the announcement of the SmallSat of the year and the poster winner. Those announcements are coming up here at the top of the hour. But in the few moments we have left, I do want to bring in all the Space News team for some key takeaways from this year's SmallSat. I just saw that the registration is now over 8,000 people. So perhaps with the on-demand viewing, they're going to triple the size of the audience that they had for last year's in-person event. My first SmallSat was probably about 20 years ago. And the perennial takeaway at that time was that SmallSats can do some amazing things if we could only afford to get them into orbit. And that remained the question for years. But obviously that chicken and egg problem has been solved. It is now very possible to get small satellites into orbit. And as a lot of our guests on today's panel have demonstrated, there are some very cool things you can do with them. Not just science missions, but there's bona fide business cases that have closed. There's real businesses flying today. I want to start with Jeff Faust, who's probably covered more small satellites than anyone else on the team. That's a given, that's for sure. Jeff, on Monday, you spoke with Dan Hart from Virgin Orbit, Peter Beck from Rocket Lab, and Brad Schneider from Firefly. You're also covering announcements from GK Launch Services this week while keeping an eye on Astra's current launch campaign. And that's just the SmallSat part of your beat. I wanted to ask you, kind of what developments are evident to you on the launch side, including both small launchers and what we're seeing with rideshare?
Yeah, I mean, this has been more of a evolutionary year rather than evolutionary year. There haven't been any sort of major announcements in terms of launch capabilities. For example, last year at SmallSat, we saw SpaceX announce its rideshare program. We saw Arianespace announce a rideshare program as well. This year it's been more about tweaking what's available and in many cases enhancing capabilities. An example is Rocket Lab. They announced this week that they're increasing the payload capacity of their Electron launch vehicle. They've made some improvements in the batteries that translates into lower mass of the batteries and therefore greater payload capacity. They also a little more quietly announced that they're going to offer a larger payload fairing as well. I think that reflects the fact that small satellites do tend to get a little bit bigger over time. 3U CubeSats become 6U CubeSats, 6Us become 12Us, and then small satellites become sort of more ESPA class satellites as well. So we're seeing sort of that evolution in the launch market to accommodate that. But at the same time, we still have a large number of vehicles that are still in development that are approaching first flights or second flights in some cases. We haven't seen quite yet that shakeout that we're expecting in the market, although we assume it's going to come at some point simply because there isn't the demand that anyone can see for dozens of small launch vehicles. So we'll see how that shakes out. But we're seeing certainly lots of capacity in the market between the small launch vehicles and the rideshare capabilities that are being provided by various companies, that, as you say, a small satellite can find a way to launch. They can find a way to orbit. No one's ever satisfied with price or availability or orbit. Everyone wants a little bit cheaper launch or a little bit more responsive, or tweaking the orbit and so on. But certainly there's a way to get there. And now it's determining what's going to be the winners in terms of the dedicated small launch vehicles, in terms of rideshare capabilities, who's going to be able to best meet the needs of an evolving market.
Thanks, Jeff. I wanted to go to Sandra now, because Sandra, this was your first SmallSat, and you focused on DoD's presence, the Defense Department's presence at this year's SmallSat, by also hosting a couple of webinars. You did one on Tuesday with DARPA's Blackjack program manager, and you did one on Wednesday with SMC. What did you glean about SmallSat interest, basically, from the NRO, SDA, SMC? Any other acronym you care to address?
Yeah, I mean, obviously there is interest by all these agencies in small satellites. The government is going to buy satellites of all sizes, obviously, but I guess when you listen to the National Reconnaissance Office, you see that they're very excited about the opportunities to do more experiments, faster, cheaper, using small satellites. So seems to be more opportunity there. On the operational side, I think we're seeing more of an aggressive push by the Space Development Agency, which is a new agency in the Pentagon that is trying to develop low Earth orbit constellation. So I think that's probably where we're going to see a more operational push. And the Blackjack program that you mentioned that we discussed on Tuesday, I mean, that they're a big partner with the Space Development Agency, and they're really leading the way in DoD using small satellites. As far as SMC, we heard from them yesterday that they're developing a national security space architecture that takes advantage of all different types of satellites, including commercial. And if you look at the presentation that they gave, and they talked about strategic space, and then they talked about tactical space, the tactical effects, where you have weather, missile warning, communications, all these different capabilities. That's where they say, we want to hear more from the commercial industry, where they're going and how we can take advantage of this. So anyway, I'm sorry this connection is not very good, but I think that definitely the answer is everyone is everyone is looking to take advantage of the opportunities, and they just want to hear more from the industry of what's available.
Sure. Now, Deborah, I saw a lot of announcements that you wrote up this week. What were some of the notable announcements you saw this week? I think your mic is you're still muted, Deborah.
Thank you. One of the things I noticed is that we had those announcements last year of these very inexpensive rideshare opportunities. And I've seen that really shake up the market in the last year. It's created a lot of demand for last mile services and for propulsion, because if you can get an inexpensive SpaceX or Arianespace ride into orbit, then you simply need to find a way to your optimal orbit. So that's been very good for Momentous with its Vigoride vehicle, which we should see fly later this year, and for Spaceflight's Sherpa. But the small companies, the startups, also see demand for chemical and electric propulsion to little tiny modules to move the small satellites where they need to go.
Thanks, Deborah. Caleb, same question for you.
Yeah, I would echo, I guess, what my colleagues have said. I think there's also some interesting rideshare opportunities or last mile services coming out of Europe, with ExoTrail having raised, I want to say it was 11 million euros earlier this year, and they also plan to develop a last mile system. And D-Orbit has one of the early models of their last mile deployers on an upcoming Vega launch. I think what Jeff was talking about as far as it being an evolution, not a revolution, one of the indicators of that is the fact that even during the launch panel that he was moderating, we were talking about missions rockets that have actually flown. Electron has flown, Launcher 1 had a mission and has another mission planned, and Firefly, I think the launch date is October. So we're not talking about a notional year or quarter or something, we're talking about a month, and actually seeing these missions happen. So yeah, I think it's a steady growth of increasing launch opportunity. We just had half a dozen SmallSat manufacturers, and we could have had a full dozen. There's so many now, so that sector has grown. I think the industry overall just seems to continue to be maturing and becoming more robust overall.
Yeah, definitely. I mean, SmallSat was virtual this year, but there's nothing virtual about the industry. We've definitely moved well beyond the paper rocket stage, the paper satellite stage. We have real businesses, real hardware, real satellites. Jeff, I wanted to get your thoughts though, as somebody who's attended this conference so often. It was virtual this year, right? It's there was a lot of content offered, but it's not quite the same as being in person. How did you deal with that, and where did you see, where did you see kind of room for engaging with folks? Where do you see room for opportunity? That's room for improvement, that sort of thing.
Yeah, I mean, there are certain advantages to having the virtual setup. You have all of the sessions pre-recorded, so you can sort of binge watch some of these sessions if you want to. The nice thing about the player that they have, you can actually watch it at sort of an advanced speed, so you can get through a 15-minute talk in 10 minutes. So there's advantages there. The disadvantage, of course, is that the interaction is a lot different, and you miss out on a lot of the personal interactions that you see in the in-person conferences. When you go to SmallSat and you run into somebody in the line for lunch, or you run into somebody in one of the receptions in the evening and have those sort of interactions, or just talking to people in the exhibit hall, you can't quite replicate that with the online version, even with chat rooms and Zoom sessions and things like that. So that's, this is better than not having a conference at all. It's obviously a good opportunity to get a feel for the pulse of the industry at this point. But I think, most of us are going to be looking forward to having an in-person conference again next year.
I would definitely agree. So we're now a little bit past the top of the hour. We've got some other sessions starting, so I don't want to keep anybody any longer than I need to. I just want to thank everybody for attending this week. We hope that you found some value in this week's SNET SmallSat webinars. I want to thank the whole Space News team for making this possible. I hope to see a lot of you next year in Logan, Utah. Thanks, everybody.
Thank you.
Thank you.
Bye-bye.